In this lesson, we will continue the previous lesson, which is about the tangents of a circle. We will take the second theorem about this lesson, which is the tangents to the circle from an external point to it are congruent. Tangent to the circle from an external point to it are congruent. What is this theorem talking about? So first of all, we need the circle, of course. So I'll draw a circle here. Okay, this is my circle. I need an external point, which is point after the circle. So this is the external point, which is this one. Now I need tangents. Tangents. It means I will make as much as I can from the tangents. From this point comes from the external point. So I have this point. I will draw the first tangent up. Okay, this is the first. This is the second. Okay, can I make more? Of course, as you see, we can't make more than 2. What they want me to prove, that they are congruent. But what they mean by the tangent, they are talking about from the point of tangency, this point first, till the exterior point that we are talking about. So the length from here, or the distance from here till this point, is the same with the distance from this point to the second point of tangency. So they are not talking from here to the exterior point. No, they're talking from the tangents point till the exterior point. Okay, so now we want to prove that the distance here, or the length of this tangent, is the same with the length of this tangent till this point. How are we gonna prove it? So let's see what's the givens. Okay, we should give them a name right now. So the first thing here we have what? A is external point, so I will need A, this point which is out of the circle, to give it we could give it a name. Also we want for the tangency names. O is a circle, so this is O. AB and AC are tangents, so AB from A to B, then from A to the second point of tangency, which is C. Now we're going to prove it. Before that, when we prove two sides are similar or are congruent, we need 2 triangles. Most of the time we need triangles, so I need triangles. I don't have here a triangles. We need 2 triangles, but I don't have. So this is the construction. The construction, what we will do, we will draw from B to O, and we're going to join O, C. So I make 2 radius. Sorry, 2 radius. And I will join from O to A. Now I have 2 triangles, which is OBA and AOC. So 2 triangles. If I prove that those 2 triangles are congruent, if I prove that they are congruent, it means this side is same with that side. So the length of this side is the same with the length of this side, and this is what they want me to prove. Before that, I drew this. I did it. It's construction. This line also, and that one. So it's picture to make it as dot. So I'll make them like this because it's not in the theorem. Those 3 lines they're not in the theorem itself. Let's start proving. First of all, in this triangle, the first one, I have OB the same with the length of OC. Why? Because they are ready in the same circle. This one, the same with that one, because they are ready. The side OA, this side is what? Is common, because it's a side in the first triangle and it's also a side in the second triangle. The third point, so we have ready first. Second, we have common side. Third, I have here a right angle. This angle, which is B, and the first one is a right angle. Why? According to the theorem 10. Theorem 10 said the angle between the radius and the tangent at the point of tangency, what is it? It's a right angle. So this is right angle according to theorem 10. I have radius and I have tangent, so the angle between them is what? Is a right angle. So this is, its measure is 90. And this angle, its measure is 90 as well, because I have radius, I have tangent, they meet each other at the point of tangency. So this angle is what? Is right angle. It means its measure is 90. So here I have B and I have C are same. Those two angles are congruent. So this is the third information. Now I did prove it. I proved that this triangle is congruent with that one. Let's see. The required, we want to prove that the length of BA is the same with CA, as we said. Okay, construction, we join OA, OB, and OC to make two triangles. The proof, we have two triangles. We have two triangles, which is ABO and ACO. The first information, which is very clear, OB, the length of OB, the same with the length of OC, because they are ready. The side OA is common. OA is common. The angle, the measure of the angle ABO, ABO, the same with the measure of the angle ACO. Theorem, which is theorem 10. So we prove that this triangle is congruent with that one. They are the same. It means the length, all the length are same. I mean, all the length from this side, or the first side here, is the same with the second side. This side also, it will be the same with the side. So the length of AB is the same with the length of AC, because the triangle are what? Are congruent. So this is the last point. The length of AB is the same with the length of AC.